Hey guys, this is Fozon, and in today's lesson we're going to be looking at the Fibonacci sequence. Our lesson objectives: learn what the Fibonacci sequence actually is, and then apply recursion to the Fibonacci sequence within the Java compiler. So what is the Fibonacci sequence? The Fibonacci sequence is a series that continuously adds the previous two numbers to get the next number. Look at the series that I have here, which is the Fibonacci sequence. It starts at 1, and it has another 1 because we can't add the last two numbers together if there are no two last numbers. So the first two numbers are going to be established as 1. Then we go on to position 2. We start at position 0, n equals 0, and then we work our way up. So position 2 is going to add the previous two numbers, n equals 0 and n equals 1. So 1 plus 1 is equal to 2. Now to get position 3, we have to add the previous two numbers. We do not add all the numbers that come before position 3. So it's going to add 1 plus 2, and it's going to get 3. And we continuously do this pattern for any Fibonacci number we want to get. So this is the function that we derive for the Fibonacci sequence. Now we have to understand what each element of the Fibonacci sequence equation entails. So the f of n is very different from just of n. Think of it like f of x from your algebra class. F of x is a function, whereas x is the position of x. Think of it the same way within a series. N is just the position that starts at 0, and it works your way up to whatever value you want in the series. Most likely, if you're doing a calculus class, it would go up to infinity, but we're not doing calculus. We're right now working with computer science. So f of n, which is the Fibonacci number for n value, is going to be equal to f of n minus 1 plus f of n minus 2, meaning it's saying that you're going to add the previous number and then the number before the previous number. So if I want to get 55, I have to add 21 plus 34, the previous two Fibonacci numbers within the sequence. The best way to visualize this is through a Fibonacci tree. So if you look within the Fibonacci tree, it makes a lot more sense how we're adding up all the numbers together. If I start off at if I want to get the Fibonacci number for f of 6, I need to work my way down. I go from f of 6 and then add what I get from f of 4 and f of 5. F of 4 and f of 5 have their own trees as well, and they can go from f of 2 to f of 3, and then those have their own Fibonacci trees. At the end of the day, you look at the children of all the trees, and then you find how the numbers are being added together. You have all our f of 0s, f of 1s, which are our base cases, or the numbers that we just start off the Fibonacci numbers with, and then we keep adding it up together, up the tree, and eventually we get the f of 6, or the Fibonacci number of 6. So how do we use Fibonacci sequence with the recursion in Java? Well, we have to look at two different cases, the base case and the recursive case. The base case is going to be f of 0 and f of 1. And the reason why that these are our two base cases is because f of 0, or the Fibonacci number of 0, really has no numbers before it. And f of 1, or the Fibonacci number of 1, only has one number before it. And since in the Fibonacci sequence, to use the recursive algorithm, we need to add the two previous numbers in order to actually derive the Fibonacci number. But we don't get this luxury with the first two numbers within the Fibonacci sequence. So they're going to be our base case, and they're both going to be set to 0. The recursive case, as I said before, is going to be it's going to be the recursive algorithm. So you're going to add the previous number and then the number before the previous number. Otherwise, you can look at this equation and it makes more sense. The Fibonacci number of n is equal to the Fibonacci number of n minus 1 plus the Fibonacci number of n minus 2. The value within the parentheses is not the Fibonacci number, it's the position within the Fibonacci series. F of n minus 1, or f of n minus 2, or f of n is the Fibonacci number. So let's code the Fibonacci sequence, or more specifically, the Fibonacci number. So in the compiler, I've already made my main method so that we can test out our Fibonacci implementation when we're done. You don't need to worry about how this works. Just know that I have a print statement that tells the user, what they're using the program for, and then it continuously runs until someone enters -1 to quit the main method or quit the program altogether. But our main goal is writing the Fibonacci sequence implementation in the second method. So let me zoom in and actually create it. The first thing I want to do is create our base case. So let's create our base cases. Base case. If you recall, we had two base cases. We had if n, because we're getting an integer n from our arguments, if n is equal to 0, the Fibonacci number for that is going to be 1. We're using return statements because we want to return the number at each respective location, and we have an integer return type within our method header. The other base case was when n is equal to 1. So let's do that. If n is equal to 1, I also want to return 1. Now here comes the fun part. When both of the base case if statements are not met, what should we be returning? We should be returning the recursive case. And what is the recursive case? Well, the recursive case is the Fibonacci number of the previous number plus the Fibonacci number of the value of the Fibonacci number before the previous value. So let's do that. So rather than returning -1 that I put just to make sure the compiler didn't do anything funky, I'm going to call on Fibonacci sequence. And then I'm going to say I want to get the value of n-1 or the Fibonacci number of n-1, and I want to add it to the Fibonacci number of n-2. And it will recursively do that until it finds a value for n-1 and n-2, all derived from our base cases. They add up all together, and eventually it will come out to the value that we have initially when we put in integer n. So let's test it out. So let me first test out 0. The Fibonacci number for 0 is 1. The Fibonacci number of 1 is 1, because those are our two base cases, and we get 1, 1. Now here comes the adding part. This is where the recursive case is going to be used at least once. So the recursive, or the Fibonacci number of 2 is going to be 2. Now we need to get the Fibonacci number of 3. So what is 1 plus 2? 1 plus 2 is 3, so the Fibonacci number of 3 is going to be 3. So up to this point, it's been like 1, 2, 3. So if this algorithm actually works, it should now return 2 plus 3, which is, well, 5. So the Fibonacci number of 4, or position 4, is going to be 5. And that's what it returns. And we can continue adding the two previous numbers to see if our algorithm works. And as you can see, our algorithm for the Fibonacci sequence works because we have both base cases, n equals 0 and n equals 1, returning 1. And we also have our recursive case that is reflective of what the Fibonacci sequence actually is, adding the two previous numbers together to get the next number.